So let's look at statistics and how they're used in research. Statistics is really using mathematics to organize, summarize, and interpret numerical data. And statistical analysis allows us researchers to draw conclusions about the data we collect. Statistics are part of everyday modern life. We see it in sports, we see it in government, we see it in health, we see it in corporate decision making. So for example, in sports, baseball being a sport that's all about statistics, looks at batting averages. In terms of government, we make economic predictions with statistics. In terms of corporate decisions, we make decisions about television shows and their popularity. There are two basic types of statistics that exist. There is the descriptive statistics and the inferential statistics. The descriptive statistics really are about organizing and summarizing data and provide some sort of overview, and inferential statistics are about interpreting data and drawing conclusions. So let's look at the descriptive statistics. Measures of central tendency are used to describe the typical or average score in a distribution. The mean is the arithmetic average and is therefore sensitive to extreme scores. The median is the score that falls exactly in the center of the distribution. And the mode is the most frequently occurring score. Which one is the most accurate description of a typical score? It depends on the data, as depicted on the next slide. In general, the mean is the most useful and measure of central tendency because additional statistical manipulations can be performed on it and that are not possible with the median or mode. However, the mean is sensitive to extreme scores and distribution, which can sometimes make them misleading. To illustrate, take a look at this example from our textbook and imagine that you're interviewing for a sales position at a company. Unbeknownst to you, the company's 5 salespeople earned the following incomes in the previous year: $20,000, $20,000, $25,000, $35,000, and $200,000. You ask how much the typical salesperson earns in a year, and the sales director proudly announced that the 5 salespeople earned a mean income of $60,000 last year, and this calculation is shown here in figure 2.7. However, before you order that expensive new sports car, you would better inquire about the median and the modal income for the sales staff. In this case, one extreme score, a $200,000 annual sales, has inflated the mean, making it unrepresentative of the sales staff's earnings. In this instance, the median, $25,000, and the mode, $20,000, both provide better estimates of what you are likely to earn. So get yourself a Honda Civic. Variability refers to how much score and a set of data vary from one another and from the mean. The standard deviation is a numerical index of variability. If the variability in a data set is high, the standard deviation will be a higher number than if the variability is low, as is evident in figure 2.6. In describing a data set, it is often useful to have some estimate of the variability among the scores. Variability refers to how much the score in a data set vary from each other and from the mean. Just as there are several measures of central tendency, there are also different measures of variability. One of the most useful measures of variability is a standard deviation. The standard deviation is an index of the amount of variability in a set of data. It gives you a measure of how much the score in your sample cluster around the average. When variability is great, the standard deviation will be large. When variability is low, the standard deviation will be smaller. This relationship is apparent if you examine the 2 sets of data in this figure 2.8. The mean is the same for both sets of scores, but variability clearly is greater in set B than in set A. This greater variability yields a higher standard deviation from set B than from set A. Estimates of variability play a crucial role when researchers use statistics to decide whether the results of their studies support the hypothesis. The standard deviation is also useful in understanding another important concept in psychology and statistics, the normal curve or the normal distribution. The normal distribution is a symmetrical bell-shaped curve that represents the pattern in which many human characteristics are dispersed in the population. A great many of physical qualities, height, nose length, and running speed, and psychological traits such as intelligence and spatial reasoning ability and introversion are distributed in a manner that closely resembles this bell-shaped curve. When a trait is normally distributed, most scores fall near the center of the distribution, the mean. And the number of scores gradually declines as one moves away from the center in either direction. The normal distribution is not a law of nature. It's a mathematical function or theoretical curve that approximates the way nature seems to operate. The normal distribution is the bedrock of the scoring system for most psychological tests, such as intelligence, and we'll discuss psychological tests in Chapter 9. Test scores such as those derived from IQ tests that place examinees in the normal distribution can always be converted to percentile scores, which are a little easier to interpret. And a percentile score indicates the percentage of people who score at or below a particular score. So for example, if you score at the 60th percentile on an IQ test, 60% of the people who take the test score the same or below you, while the remaining 40% score above you. There are tables available that permit us to convert any standard deviation placement in a normal distribution into precise percentile scores. And if we look at this figure 2.9, it gives some percentile conversions for the normal curve. Of course, not all distributions are normal, and spatial statistical operations may be necessary when distributions depart significantly from normality. A correlation exists when two variables are related to each other. The correlation coefficient is a numerical index of the strength and direction of association between two variables. A correlation is expressed as a number between 1 and 0, and the number may be positive and or negative. The closer to 1 the number is, whether plus 1 or negative 1, the stronger the relationship between the variables. So for example, a correlation of 0.17 is pretty weak, while a correlation of 0.89 is pretty strong. The positive-negative dimension of the correlation coefficient expresses the direction of the relationship. If two variables are positively correlated, they may covary in the same direction. As scores on one variable go up, scores on another variable will go up too. If two variables are negatively correlated, the variables covary in the opposite direction. As one goes up, the other one goes down. As a correlation increases in strength, closer to negative or plus 1, the ability to predict one variable based on knowledge of the other variable increases. So for example, SAT scores are correlated with first-year college GPA in the United States at a moderate 0.40 to 0.50. This may not be perfect, but it allows admission committees to predict with some accuracy how well a prospective student will do in college. And although correlation may allow prediction, it does not infer cause and effect. For example, a strong positive correlation has been shown between foot size in children and vocabulary. As foot size increases, so does vocabulary. Do bigger feet make children learn more words? No. It's a third variable, age, which causes both feet and vocabulary to grow. Researchers use inferential statistics to determine whether their data supports their hypotheses. With these statistical methods, they can interpret data and draw conclusions. Inferential statistics use laws of probability to allow researchers to determine how likely it is that their findings are real, that is, not due to chance. Statistical significance is said to exist when the probability that is observed findings are due to chance is very low. Many psychologists see very low as fewer than 5 chances in 100 that results are not real, the level 0.05 level of significance. So let's look at flaws and how we evaluate research. So first of all, sampling bias. When a sample is not representative of a population, so for example, if we poll only men, the outcome of that poll may be different than if we polled both women and men. Weird, stands for Western, educated, industrialized, rich, and democratic, and this represents a criticism of science's heavy reliance on particular type of human participant. This likely affects many research outcomes and highlights the importance of cross-cultural research. Placebo effect is when a participant's expectations lead them to experience some change even though they receive empty, fake, or ineffectual treatment. For example, when subjects are cured by a sugar pill. Distortions in self-report data can also occur. Social desirability bias is a tendency to give social approval answers to questions about oneself. For example, did you vote? And if you didn't vote, you may have said yes, even though you didn't. Response set is a tendency to respond to questions in a particular way. So, for example, that you agree with everything together in a question set. The Halo effect is the tendency to let initial performance or liking affect future judgments or performance. Experimenter bias is when a researcher's expectations or preferences about the outcome of a study influence the results obtained. Researchers see what they want to see, and errors are usually in favor of their own hypothesis. Similarly, researchers may unintentionally influence the behavior of their subjects, possibly through body language, smiles, and other tactics, known or unknown. To control for this problem, a double-blind procedure in which neither subject nor experimenters know which subjects are in the experiment and which are in the control group is used. And in this case, a non-directly involved researcher keeps track of everything. So let's look a little bit at the ethics of research. Do the ends justify the means? Let's look at the question of deception. Is it okay to make subjects think they are hurting others, have homosexual tendencies, think they are overhearing negative comments about themselves? What about animal research? Controversy regarding humane treatment of animals versus no use of animals in research has evolved tremendously in the past 30 to 50 years. These and other ethical issues have led the American Psychological Association to develop a set of ethical standards for research to ensure that both human and animal subjects are treated with dignity. I encourage you to look at a variety of links around the ethics of research that I provided you in our Blackboard shell to give you an understanding of how we outweigh the risks and benefits using an ethical model in terms of when we interact and when we plan and when we implement psychological research.